This Algebra Nation podcast will cover page 129, problem number 4.
Expression below. Which answer choice represents the expression below? Factored completely. That's the key right there, that this is an expression, but it's not factored. So we have to factor it. So the way we're going to look at this is say, okay, in this expression there are 3 different terms, and we have to see what each one of those terms share. Okay, we have to see what all of those terms share, maybe in terms of a coefficient that they share, a factor for the coefficients, maybe they share some variables. So we have to figure out what they share, what they have in common. Okay, so the way that I like to start these is I start with my coefficients. So we're going to take a look at these coefficients, 12, 57, and 36. Okay, 12, 57, and 36. And what we have to do is ask ourselves, what is maybe a factor, right, that can go into 12, that can go into 57, and that can go into 36? Well, the way that I'm going to kind of ask myself this is, okay, 12 seems like the simplest of those 3 coefficients. So I'm going to ask myself, what are the factors of 12? Okay, what are the factors of 12? Well, if I'm going to do a factor tree for 12, I know that that's 2 times 6. And then for 6, I know that I can break that up into 2 times 3. So then my factors of 12 are 2, 2, and 3. Okay, I can take a look just by looking at 57 and know that 2 is not a factor of 57 because 57 is odd. But is 3 a factor of 57? And is 3 a factor of 36? Well, I don't know. Let's take a look. So if we have our calculator, we know that we can take 57 divided by 3 to see if 3 is a factor of 57. Oh, goes into it 19 times. So yes, it is. Well, what about 36? And all I'm doing right now is double checking to see if 3 is a factor of all 3 of those coefficients. So 36 divided by 3 is 12. So yes, 3 is a factor of 36 as well. So now what does that mean? That means that I can factor out a 3 from each one of these terms. So now that's going to be something that's on the outside of my parentheses. So when I factor out, it's almost like the opposite of distributing. Okay, well then now, are there any variables that each one of those terms share? Let's take it one at a time. Let's look at our a's first. So we know that we have a squared, we have an a in the second term, but then there's no a in this third term. So a is not a term or not a factor that is shared by each one of those terms, right? It's not a factor that's shared by each one of those terms. Now let's look at b's, where we have 1b in that first term, we have 1b in the second term, and 1b in the third term. So yeah, bingo, right? We see that b is shared by all 3 of those terms. So I can factor out a b as well. So whenever I factor out, that means that I'm taking out that 3b, since that is shared as a factor of each one of those terms. But then now, what am I left with? Well, really what I'm doing is I'm taking each one of those terms and I'm dividing them by 3b. So if I take the 12 divided by that 3, I'm left with 4. And since I factored out the b, it's like I got rid of that b. I divided it by b, so it's not there anymore. So I'm just left with 4a squared. And I can kind of double check this. If I multiply 4a squared times 3b, I get 12a squared b. That's what I'm left when I have this expression, which is what I started with. But remember, I'm factoring out. So here I have this 3b times that 4a squared, which is what I'm left with. Okay, this 57, when we take 57 divided by 3, we're left with 19. So the 19 is going to be my coefficient, and I factored out the b, so the b goes away, and I'm just left with a. And then last but not least, 36 divided by 3 is 12. So I know that 12 is going to be my coefficient, and I factored out the b, so that's just what I'm left with right there. 4a squared plus 19a plus 12 on the inside of my parentheses, because I factored out this 3b right here. So then I take a look at my answer choices, and I see that that looks like answer choice B. I cannot factor this anymore. Well, let's ask myself, can I factor this anymore? Okay, can I factor that? Well, if we were going to factor this expression right here, this inside of the parentheses expression,
I think you should ask yourself for a brain break. Because whatever you do, you don't want to be denied on the EOC like this clown. Take away his drink. Get that garbage out of here. Not worthy of a $3.99. All right, focus.
we would have to come up with a number that multiplies to be 48 and adds to be 19. multiplies to be 48, and adds to be 19. Okay, is there a combination, two different numbers, that multiply to be 48 and add to be 19? Let's ask ourselves, well, for 48, if we're trying to figure out two numbers that multiply to be 48, let's just write out the combinations of how we can multiply to get 48. 1 times 48, 2 times 24, right? 3 times 16, 4 times 12, yep, is 48. And this will come with practice. As long as you do this over and over again, you will get way better with learning, what two numbers multiply to be that 48. Well, remember, I'm trying to figure out two numbers that add to be 19. Well, if I take a look, I have 3 times 16. So when I thought that I was done factoring, what I can kind of realize now is that this inside of the parentheses term can be factored even further. All right, so what I'm going to do is rewrite my expression now as 3b times 4a squared plus 19a plus 12. All right, I have that rewritten now. Then I take a look and see, okay, since I have two numbers that multiply to be that 48, since that was 12 times 4, and the add to be the middle number, 19, I see that, yeah, that's 3 and 16. So 3 and 16 add up to be 19, so that's what I'm going to use. So here, whenever I have the 3b on the outside, I can't forget about that. So I have 3b. But then now what I'm going to do is I'm going to break up this 19a to be 3a plus 16a. So I have 4a squared, because those were the two numbers, right? Those two numbers that I needed were 3 and 16. So plus 3a plus 16a plus 12. All right, so now what we're going to do is factor by grouping. That's one of the best ways that I like to do this, but there are multiple ways. So if you're more comfortable with a different way, please share it on the wall, or just stick to the way that you are very comfortable with, okay? So here, whenever I'm going to group them, I'm going to say, okay, these first two terms, I'm going to group them together, and the second two terms, I'm going to group them together, okay? And you would eventually get the same answer no matter how you decided to group them. Okay, so here I've got 4a and 3a, so what I have to do is say, okay, what do each one of those terms share? Well, they don't share a coefficient, because 4 and 3, they don't have any common factors there, but they do share an a. So again, I can't forget about that 3b out in front. But what I'm going to say is that on the inside now, this first grouped pair of terms, they share an a. So I can factor out that a. What I'm left with is just 4a plus 3. But then now for my second two terms, right? My second two terms, I'm going to ask, what do they share? Well, they don't share any a's, they don't share any variables, but do they share any factors of their coefficients? Does this constant share any factors with that coefficient of 16? Well, obviously 2 goes into both of them, but if we think a little bit deeper, we can see that 4 will go into 12 and 4 will go into 16, so we can factor out a 4. Whenever we factor out 4, what we're left with on the inside, whenever we divide this 16a by 4, we are left with 4a, and we are left with 3 for that 12 right there. Close off my parentheses completely, and then now I'm almost done. I am almost completely done. I can see that this term right here, a times 4a plus 3, plus this term right here, 4 times 4a plus 3, what do those have in common? What do those share? Well, because they share a 4a plus 3, it's almost like I can factor out that 4a plus 3. So one of my terms for my factored version of 4a squared plus 19a plus 12, one of my terms is going to be that 4a plus 3. But then my other term is going to be what I'm left with on the outside of those parentheses right there, a plus 4, right? A plus 4. Everybody see that? A plus 4. So that's going to be my second term. Because really what I've done is I've factored out that 4a plus 3, so that now all I'm left with is that a plus 4. Can't forget about my 3b out in front. Then now I see that that is the factored version completely of my original expression, my original polynomial. All right, anybody have any questions about this? Good. So then we realize that after we factored it even further, that it's not answer choice B, but that it's actually answer choice D right there. All right, so always ask yourself, if you're left with a 3-term expression, can I factor this further? All right, so it's almost